सो टुडे वी आर गोइंग टू स्टार्ट विद द एडर। आज हम एडर पढ़ेंगे। कंप्यूटर सिस्टम आर्किटेक्चर में एडर क्या होता है? सो एन एडर इज़ अ डिजिटल सर्किट दैट परफॉर्म्स एडिशन ऑफ टू नंबर्स। सो इफ़ आई टॉक अबाउट एन एडर, तो एडर एक आपका डिजिटल सर्किट है जो कि एडिशन ऑफ नंबर्स परफॉर्म करता है। सो फर्स्ट पॉइंट सेज इफ़ यू वांट टू परफॉर्म एडिशन ऑफ नंबर्स, then the digital circuit known as adder is being used. Adders are used in arithmetic logical units. So second point says that the adders are used in ALUs, which is embedded in CPUs. There are two types of adders. First is half adder and second is full adder. तो अगर हम adder के types की बात करते हैं, we have right now we are studying half adder and two adder. So let's move further with half adder. And half adder is an arithmetic circuit which needs two binary inputs and two binary outputs to perform addition. तो in simple language, अगर मैं हाफ एडर की बात करता हूँ तो उसके अंदर दो बाइनरी इनपुट्स होंगे, जैसे यहाँ पे आप देख सकते हो A और B, और उसके अंदर दो आउटपुट होंगे S which is sum and C which is carry. So let's talk about the truth table of this. The truth table is as follows. हमारे पास दो इनपुट वेरिएबल्स हैं A और B, और सम और कैरी हमारे आउटपुट वेरिएबल्स हैं। तो अगर मैं A B 0 0 रखता हूँ तो 0 plus 0 is 0 in sum and carry is also 0. If I put A as 0 and B as 1, then the sum will be 1 and carry will be 0. Similarly, if I put value of A as 1 and B as 0, then 1 plus 0 is 1, which is sum, and carry is 0. On the other hand, if I talk about A value as 1 and B as also 1, then the output will be 2. So let me write down the output. The output will be 2, which is written as 1 0 in binary, where 0 is being written over here as a sum and 1 is used for the carry. So this is a logic which is being used in a truth table to represent if the value of A and B is 1 each. So let's move towards the circuit diagram, logic circuit diagram. I have two inputs A and B. So over here in this truth table, first we will find out the sum in some column which values are having one value. So these two which I have marked, the values are one of some column. So I will take these two variables where value of A will be A dash. If I select first one, and the value of B will be B because B is 1. Similarly, in this case the value of A will be 1, so it will be A, and value of B will be B dash because value of B is 0 over here. So you can see the value of first one is here, which is A dash B, and again the plus operator is being used, and value of B over here, the combination of output, which is A dot B dash. So over here I am getting the sum for the carry. I will take the value of 1 over here from here, and I will check these two values which are A and B, both are 1. So AND gate will be used, and C is equal to A dot P, where A is 1 and B is also 1. So 1 dot 1 is over here. So this is the logic diagram which I have used over here from this truth table. So let's move further and understand the K-map. So to understand the K-map from the truth table, what we have to do, हमें ये वैल्यू जो यहाँ पे आपको दिख रही है 1 और वैल्यू जो 2 है, इसको हमें के मैप में हमें इसको इंसर्ट करना है, मार्क करना है, और एस जो आपका यहाँ पे वेरिएबल है, ठीक है, इसको हम कैसे रिप्रेजेंट करेंगे, ए एंड बी ओवर हियर. सो फर्स्ट वैल्यू यू कैन सी, यहाँ पे पहली वैल्यू है 1 एंड सेकेंड इज़ 2. सो दिस इज़ 0, दिस इज़ 1, दिस इज़ 2 एंड दिस इज़ 3. तो हमारे पास 1 और 2 वैल्यू हमारी सम वाला जो कॉलम है उसके अंदर है, तो मैंने 1 और 1 वहाँ मार्क कर लिया है, और फिर उसके बाद मैंने इनकी एक्सप्रेशन लिख ली है. तो पहले मैं इसकी एक्सप्रेशन लिखता हूँ। ये पहला वाला जो वन है, सो यहाँ पे अगर हम देखेंगे तो ए डैश है और यहाँ पे हम देखेंगे बी है, क्योंकि यहाँ पे कोई भी ग्रुप नहीं बन रहा है, तो ए डैश बी बन गया हमारा। फिर प्लस ऑपरेटर लगाएंगे और फिर नेक्स्ट वाला हम वैल्यू चेक करेंगे। तो यहाँ पे वैल्यू है ए और बी की वैल्यू है बी डैश, तो ए एंड बी डैश, जिसको हम लिख सकते हैं ए प्लस बी डैश के फॉर्म में। अब आगे बढ़ते हैं और कैरी का देखते हैं। कैरी वाले कॉलम में हम यहाँ पे चेक करते हैं। कैरी वाले कॉलम में यहाँ पे 3 पे जो है आपका 1 है, तो के मैप के अंदर हम 3 कहाँ पे लिखते हैं, आपको भी पता है 2 वेरिएबल के मैप में, तो 0 1 2 3, तो 3 यहाँ पर है, तो 3 को मैंने मार्क कर दिया है, क्योंकि यहाँ पे कॉलम वाले कैरी वाले कॉलम में 1 यहाँ पर है जो कि 3 है। फिर अब हम क्या करेंगे, अब हम यहाँ पे इसको इस वैल्यू को लेंगे, ये आपका हो जाएगा ए और ये आपका हो जाएगा बी, तो ए डॉट बी, तो कैरी इज इक्वल टू ए डॉट बी। So now let's talk about full adder. So half adder we have done. So let's talk about full adder. A full adder is an adder which adds 3 inputs and produce 2 outputs. The first 2 inputs are A and B, and third input is carry, which is written as C hyphen in. The output carry is designated as C out, and the normal output is designated as S, which is sum. So to understand full adder, let's check this block diagram. We have A, B and C, 3 inputs over here. Sum and carry are the outputs. So if I let's move towards the truth table and find out how it works. So if I put the value of A, B and C 0 0 0, then the sum will be 0 and carry will be 0. So it means to say that if I put value of A as 0, B as 0 and C as 0, then the sum will be 0 and carry will be 0. So the similar thing has been mentioned over here. The sum will be 0 and carry will be 0. And if I talk about the next value, if I talk about the next value is 0 0 1, then the sum will be 1 and the carry will be 0. So you can check over here in this. If I talk about 0 0 1, the sum will be 1, the carry will be 0. Similarly, if I talk about these 3 values 0 1 0, the sum will be 1 because 0 plus 1 plus 0 will be 1 and carry will be 0. Similarly, for the next one, 0 plus 1 plus 1 will be 2, and 2 is written as 1 0, so 0 will come over here and 1 will come over here. To make you understand, 2 is the output, it can be written at 1 0. So 0 will come over here as a sum and 1 will move for the carry. Similarly, for the next, we have 1 plus 0 plus 0, which is sum as 1 and carry is 0. If I talk about 0 1 0 1, the output as a sum will be 0 and carry will be 1. If I talk about next value 1 1 0, the sum will be 0 and the carry will be 1. If I talk about 1 plus 1 plus 1, then it will be 3, and 3 is written as 1 1, where 1 is written over here as a sum and next one is for the carry. So this is the way through which the truth table is been created for full adder. So let's move towards the K map of 3 variable truth table, which I have just drawn over here for full adder. So for the to represent the sum in the K map, let me move further. So what we have to do, we have to mark those values which are 1 in the over here in the K map. So in the K map, the values in the sum column are being marked over here as 0, 1 is over here, 2 is over here, 4 is over here and 7 is over here. So all these 4 values are being marked in sum column, which are marked as 1. So since I cannot make any group among these values, so the output of this expression will be, so let me write down the output over here, or should I let me write down the output over here. So the first value is this, which is A dash, B dash and C in. So I can write A dash, B dash and C in. This is my first value. For this it is, for this one it is A dash B C dash for in. Similarly for this one it is A B dash C dash for C in, and for this one it is A B C, it is over here. So you can check these values which are being calculated according to the K-map, and these values you can find over here. So for the sum expression the values are over here. Similarly we will find the value of carry. So for the carry I have created a K-map and I have marked these values which are mentioned in the column of carry. So 1 1 1 1, these 4 ones I have chosen because the output is 1, and I will mark these values over here in the K-map. So after marking these values I will make the group and minimize this values in the K-map, minimize the expression and make the group. First I will make the groups, then I will minimize it. So at the end I will get carry is equal to AB. How the AB is been written, so let's check it out. If I am choosing this column, then obviously value of A dash is in converting to A, so it will be ignored, and B C in will be written. Similarly for this group I am taking A, and above I will check which value is being changed. So B is changing from B dash to B, so B will be ignored, so it will be A C N. Similarly if I talk about this group, here the value will be A, and above I will check which value is changing. So C dash and C is changing, so I will ignore these value and B will be there. So A B will be the output. So you can check over here, and the expression is over here of reduced form of the carry. So this is a way through which we can represent the values of carry and sum in the K-map.